Hi, everyone. Welcome to our Ignite session, Getting Started with Azure AI. I'm Sherry Yang. I'm a content developer on the Data and AI team, and I'll be one of your event moderators. We have some other awesome Microsofties not on camera who will be answering your questions today in the chat. It's my pleasure to introduce your speaker, Graham Malcolm. Graham is a principal content development PM on our data science and AI team at Microsoft. As an experienced software engineer, he specializes in machine learning and AI on the Azure platform. His recent projects include developing the certification content for AI fundamentals, AI engineering, and data science. All right, take it away, Graham.
Thanks, Sherry, and welcome aboard, everyone. Glad to have you with us. Thanks to Sherry and all the other moderators on the call. As I go through this, please just post your questions in the Q&A chat, and we will deal with them as we go through. And then there'll be some time at the end for a few final questions and answers as well. But what we're going to try and do is in 30 minutes, do an exploration of AI on the Azure platform, which is quite a big ask because there's a lot of things we can do with AI on the Azure platform. So let's dive straight in, and hopefully you can see my screen, and we'll take a look at some stuff that hopefully you will find interesting. So I guess the first thing really is to kind of put a definition around what do we mean by AI? What is artificial intelligence? And the truth is there are lots and lots of different definitions of AI. If you ask different people, you'll get different opinions, some of them very technical, some of them very philosophical. But what I like to do is to kind of keep a fairly simple definition in mind for me. I think of AI as being smart software, so software that appears to be intelligent. And by that, I mean it exhibits human-like capabilities. It does the sort of things you would typically expect a human to be able to do. So, for example, it can make decisions based on historical information, or it can predict what's going to happen, or it can spot when something's not quite right, perhaps when there's an anomaly. Or it can do things that humans can do, like visual perception. It can see the world visually. It can understand visual input through cameras or images or videos or whatever. And also it can perhaps participate in natural language conversations. It can understand natural language, whether that's in speech or in writing. It can make semantic sense of language that you might use if you were conversing with another human. So those are kind of the touch points, the kind of key indicators that something is AI. Those types of capabilities are a pretty good way for me to think about when I say AI. That's the sort of thing I mean. So let's dive in and take a look at what sort of things we might do with AI. And the first thing I want to look at is machine learning. Machine learning really is the kind of foundation that most modern AI is based on. Not everything is based on machine learning in the AI world, but certainly most of it. Increasingly, as we build AI systems, they are based on underlying machine learning models. So I want us to get an understanding of a little bit of how machine learning works and what it does and what sort of things it can do. And then we'll build on that as we explore some of these other kind of more human-like capabilities that we see in AI systems. So to start off understanding machine learning, I want us to explore a little bit of data. Everything starts with data in the machine learning world. And we're going to look at some data. This is genuine data from a bike sharing scheme. It's a few years old now, but it's genuine data. So I'm just going to run it and get a little sample of some data here. I've got 10 sample records. And what we've got is a whole bunch of information about different days of the week. And if I scroll along to the right, the number of bike rentals that this particular rental agency, that this bike sharing scheme actually recorded that day. So I've got historical data. Some of it relates to the day or the time of the year. So it's kind of temporal data. I've got the day, the month, the year, the season. So 1 for spring, 2 for summer, so on. Whether or not this particular day was a holiday, whether it was which day of the week it was. So 0 for Sunday, 1 for Monday, and so on. Whether or not that was a working day. And the weather situation, which is an encoded value between 1 and 3, just to indicate whether there was clear sunshine or some precipitation or heavy wind, the temperature and the air temperature and the humidity and the wind speed. So I've got a fair amount of kind of meteorological data as well as my temporal data and the number of rentals on that day. Now, the aim of the game here, the goal here, is to try and use all of these features of a day, all of this information about the time of year, the day of the week, and so on, and all the meteorological data, and use that to try and predict how many rentals we think we will have on one particular day. And that might be useful. That's a skill in predicting how many rentals we expect to have that would be useful for things like capacity planning, or making sure that I have enough staff in place, or that I've got enough bikes ready to be rented or whatever. So we're going to try and train a machine learning model that takes all of these features and predicts the number of rentals. And to do that, I'm going to use a tool called Azure Machine Learning. So I'll go pop over to Azure Machine Learning. Here it is here. This is Azure Machine Learning Studio. This is the user interface for working with Azure Machine Learning. And there's a whole bunch of different things I can do in here. It's a very comprehensive platform for building machine learning models. I'm going to use something called automated ML, which is a nice, easy way to get started building a machine learning model from some existing data. And as it happens, we already have some existing data. We have our bike rental data. So I could create a new automated machine learning run, and I can select that bike rental data. That's what I want to create a model from. I've already uploaded that as a data set to my workspace here. And I can then, based on that data set, get it to go in and automatically train a machine learning model. So it's just going to load up that data and ask me what I want to do. To do this, we're going to run something called an experiment. And I could either create a brand new experiment or rerun an existing one. And I've already got one here called bike rental, so we'll select that. And the key thing that I want to do is I want to target the column. What's the column that I want to predict? So I've got some data that includes values for the number of rentals. So I want to use the fact that I've got that historical data to try and find a relationship between all of those other features of the day and the weather, and find out what's the correlation, what's the relationship between those and the number of rentals, and from that generate a model that can predict the number of rentals when I don't know it. Now that is going to require some computation. So to do that, I'm going to have to run that on some compute. And one of the nice things about Azure Machine Learning is it allows me to define cloud-based compute. I've got a cluster here that sits in the cloud, and I can run my experiment on that cloud, that cloud compute, and I only pay for it when I'm actually using it. So it's going to spin up the compute, run the experiment, and then when it's finished, that comes down. So it lets me scale on demand. It's one of the benefits of working in the cloud. Now, the next thing I have to do is decide what type of machine learning model I'm building. And there are various different types of machine learning. If you're brand new to machine learning, the key thing to understand here is that we are trying to predict a numeric value. So this is what we typically call a regression problem. I'm trying to find a regression line that will enable me to identify a specific numeric value. Now I could go ahead and I could set up some additional configuration settings. So I could specify, how do I want to measure the performance of this model? Remember, I've already got some data where I know the number of rentals, so I can use that to validate the model that I create. I can train a model with some of the data and then test it with the other data and see how well it predicts when I actually know the value. And I can choose what measure I want to use to determine how well it's predicting. There's a number of different measurements here. We don't really need to go into the details of these. They're all kind of statistical metrics that I can apply. I'm going to use something called normalized root mean squared error, which sounds awfully fancy, but it's really just a fancy way of saying how far away are my predictions, right? How much error is there in my model? So obviously, the lower that value, the better my model is predicting. There's less error in the model. It tends to be more accurate. And I can get it to explain the best model. I can get it to say, hey, what are the features that are influencing the prediction most? And that might be a useful thing to know. And I can specify the algorithms that I do or don't want to use. And algorithms basically are just mathematical formula. You can think of them as recipes where I pass in the information that I want it to work with. So in this case, the features of the day and the label that I'm trying to predict, the number of rentals. And it will figure out what's the relationship. What do I have to do with these feature numbers in order to calculate the label number, in order to calculate the number of rentals. So it's trying to figure out a function effectively, and that's what my model will be. When I train the model, I'll end up with a function that I pass in the features and I get out the number of rentals. So in this case, I'm just going to choose all of the available algorithms, and I'll run my experiment, and it will just try all of those different algorithms. It will try various combinations of preparing the features, scaling them to between different values and that type of thing, and come up with a model. Now, save us a little bit of time. We've only got 30 minutes, so I've actually already done all this. So I'll close this down, and let's look at the one that we've already run. Here it is here, and I previously ran it. So let's look at my experiment that ran. And I can see straight away, if I look at the models tab here, I can see that it tried a whole bunch of different models, a variety of different algorithms, a light GBM and a random forest algorithm, and it tried scaling the data differently. So it tried all sorts of ways to prepare and train a model using the algorithms that I told it to try. And the best result that I got, the one that gave me the lowest normalized root mean squared error, if you remember, that was my metric, is this one here. It's just under 0.08 was the metric that I got. So that's based on the metric I told it to use, that's the best performing model that I got from that. And I can go and have a look at that model. And I can look at things like the explanations of that model. So if I take a look at this explanation here, and I'm specifically going to look at the feature importance, it's telling me that the working day was the most important feature, followed by the temperature, which sort of makes sense. I'm probably going to get more rentals at the weekend and probably more rentals on warmer days. So I get those features, and then the rest of the features are listed in order as well. And I could look at the metrics for that experiment, and there's my normalized root mean squared. That was the metric I was interested in. There are some other metrics I can use to measure how well the model is performing, but the one I cared about really was this normalized root mean squared error. And I've got this little chart here that shows me the predicted value against the true value. So predicted value up there on the y-axis, and the true value across on the x-axis. And what I should see, with a perfect model, I would get a straight diagonal line that goes up there where the prediction is always exactly the same as the true value. Now, in reality, it isn't exactly a straight line, but it's pretty straight most of the way up. It starts to veer away as it gets near the end here. I get to the higher values where there's a lot of rentals. There's a little more error in the model up here. But if I look at this histogram underneath, I can see that on most occasions, most of the days that I rent, the numbers are usually down this area. These are the kind of high instances, the number of times that's the number of rentals on those days. So for those kind of the bulk of the time, it seems to be actually pretty accurate. I seem to have a pretty decent model here. So what I might want to do with that model is I might want to deploy that so that I can use it in an application, and I would give it a name and deploy it to some service in the cloud. I could choose a Kubernetes service or a container instance. You don't really need to worry about the details of that. Basically, all I'm doing is publishing this thing so that I end up with an endpoint. And if I have a look at my endpoint, you can see I've already published this one. And that endpoint is basically just an HTTP address. If I go and take a look at that, you can see there's an HTTP address that I can use to consume that model. So I've gone all the way from getting this Azure Machine Learning to train my model based on my data. I've then published that model, I've deployed it as an endpoint. And what that means is that if I go back to my code here, I could build a client application, and this is just some very simple code. Again, don't worry too much about the details, but I'm connecting to my endpoint. I need to pass up a key there to authenticate myself as well. And I've got here a list of 5 days worth of data. So maybe I've got the next 5 days weather forecast, and I want to try and predict how many bike rentals I'm going to need for those 5 days. And I'm going to pass that up to my published endpoint, and I'm going to get back the predictions. If I go ahead and run that code, sure enough, I get back my predictions. On day 1, we reckon 624, on day 2, 313, and so on. So I've used some data to train a model. I've taken that data, I've used an algorithm to fit that to a model that is able to take in some of those features, those values that I know, and predict values that I don't. And that's kind of the bedrock of AI, a lot of the AI systems that we use today. So let's look at another example. And this time, instead of having data in the form of numbers and measurements of the weather and so on, what if the data was visual? What if the information that was coming in that I wanted to predict from was something that I can actually see, maybe a video stream or something that we would think of as being visual perception? So the example I want to use, imagine that you're in your local grocery store, and you're buying your healthy fruit and veg, because I know we're all very conscious of our health these days. So we want to buy these things. Rather than have to have sticky labels with barcodes on all of my produce, I just want to have a camera that will look at these things and tell me that's a banana, that's an apple, that's an orange, and it knows what those things are in order to then charge me the right price for them. And that's something that we see today increasingly in different retail environments, where we use kind of visual perception to understand what the things are that we're buying. So how might I go about implementing something like that? Well, again, there is a service that I can use on Azure. It's called the Custom Vision service. It's one of the cognitive services that we have, and I'll just go and find the right page. Here it is. So there is a portal here where I have created a custom vision project called grocery detection. So we'll take a look at that project. And what I've done with this is I've already uploaded a bunch of data, a bunch of pictures of different fruit and veg, or in this case, all fruit. So I've uploaded those. That's my data. Just like I had data for the days of the week and the weather for my bike rentals, I've got data here in the form of images. And images to a computer are just numbers. These are just arrays of numbers. What I've also done with these is, if you have a look at those images, I have tagged on these the different objects. So it says that's an apple, that's an orange, and we could go through and find various others. There's one where we've got a banana. So I've tagged these and said that's what these things are. So I'm using this to do exactly what I did before. I'm training a model. So I would go and run train. I've actually already run that. I've trained that model, and it learns to create a relationship between the images that it's seeing, the data in those images, and the locations and names of the things in the images. So it's able to find those objects within the images. And I've got some results here, some metrics. We get different metrics when we work with this. It's a kind of a form of classification, this, although it's actually object detection. So I get these kind of classification metrics, but they're all pretty high. It seems to be performing pretty well. It seems to be detecting those objects pretty well based on the training data. And again, just like I did with my machine learning model, I can publish this. You can see it's got unpublished because I've already published it. And I've got a prediction URL. So again, I've got an HTTP endpoint that this model is published to. And that means, just as before, that I can write some code, build an application. Again, I've got my endpoint and I've got a key that I authenticate with. I've also got the ID of the model that I use. So I've got this project ID. And I am going to pass that up an image, and you can see the image here is called produce.jpg. Let's actually take a look at that. So here is the image that I'm going to send up. Now, this wasn't included in the training data. This wasn't an image that the model was trained with. So it's a brand new image that it's never seen before. And I'm going to pass that up in my code and get back a prediction of the objects that are in it. So we'll go and run that code. And it's detecting objects in that. And there we go. It's now gone and analyzed that image, and it's found I'm 99.29% confident this is a banana. I'm 99.56% confident this is an orange, and I'm 99.52% confident this is an apple. So just by training that model with just a handful of images, I think there were around 24 images or something like that, I've trained that model, and it is now able to identify those objects within new images that it hasn't seen before. So again, built on machine learning, but now using that human capability of visual perception. It's able to actually perceive visual data. So if we can build models that can understand the world visually, what about using language? What about models that I can speak to, or I could type information to, and they can understand the language that I'm communicating with? Well, again, we can do that. And the common example is, you know, most of you probably got something like this in your home, where you've got a little device, you bark orders at it and it obeys you. It turns the lights on or off, or locks the door, or whatever it is you tell it to do. So how can I build something that understands when I tell it to do something, when I have some language? And once again, it will shock and amaze you to know that there is a service in Azure that we can use to do this. It's called the Language Understanding Service. Again, it's one of our cognitive services. And I've got this portal where I can create one of these types of models. I've already created one called Home Automation, which I'll just open up. And it's a very, very simple model in this case. We could build much more complex models than this, but I've deliberately kept it very simple. it has three what we call intents. And an intent is basically just something that the model understands, where it knows what I want to do, right? In this case, I've got a switch on intent, and it knows that this means, okay, if I get a message like turn the fan on or turn the light on, the intent is I want to switch something on, right? That's what I want to accomplish. So I have an intent of switch on, and within that intent, I've identified specific entities. So I've got a fan and a light, for example, and these are both examples of a device entity. So this intent is a general purpose intent to say, I want to switch something on, and the thing I want to switch on is whatever the entity is, whatever the device entity is that I specify. It might be a fan, it might be a light, it might be the TV, it might be anything else that you would switch on. And similarly, I have a switch off intent where I can say turn the fan off, turn the light on. And these utterances here, these kind of sentences where I've specified these are the examples that I've given it in order to train the model. So again, we're putting some data in and we're using that data to train a model, and we're training a language understanding model in this case, so that it understands that when I see a phrase that looks a bit like this, it doesn't have to be exactly like that, but when I see a phrase that looks like this, it means I want to switch something off, right? That's the intent that this thing relates to. There is actually also a none intent, just for phrases that I might want it to understand but not really do anything with. So things like goodbye or hello, yes, it knows what those means, it just doesn't necessarily have to do anything with them. So I've taken this, I've trained a model based on this, and I have published a model based on this. And you should be seeing a pattern now of how we do this thing. We add some data, we define the model, we train the model, and then we publish the model so that we can then use it. And this, once again, is published to an endpoint that I can consume from a client application. So if I go back to my code and scroll down a little bit, I've got some code here that is going to get my prediction endpoint, and I've got my key in the app ID to identify which model it is I want to work with. And I'm going to connect to that, and I'm just going to simply enter a command. I'm going to type in a command, and it should understand that command. Now, if you remember, it was trained with things like turn on the light. So I'm going to use something different. I'm going to say switch the light on. So that's not exactly what it was trained with. And it's down here. There we go. So it has in fact understood switch on. The intent was switch on, the device was light. And I could try that again with, let's say, switch off the fan. Again, we'll scroll down and get the result. And yet it understood intent was switch off, the device was fan, it switched off the fan. So it's able to interpret my natural language input and figure out what the intent is and what the entities are that I've mentioned in that, even though it's not exactly what it was trained with. Now, the big question is, of course, in reality, if I did this at home, I wouldn't type into my device to turn on the light or whatever. I would actually speak to it. So can I do that as well? Can I actually do this with speech? And the answer is yes. We have, in addition to the language understanding service, there is a speech cognitive service that integrates with the language understanding service. And I can not only speak instructions to it, but I can actually get it to synthesize the responses back. So we'll try this. I don't know if my microphone will pick it up or not, but we'll try this, where I'm going to speak to the device or speak to the service and get it to understand my input and then speak back to me. Turn the light on.
Okay, I'll switch on the light.
And sure enough, it understands what I've asked it to do, and it switches on the light for me. So I'm now able to use natural language, just as I would with a human, to communicate with this device that I've got. And it gives me that AI capability of understanding natural language and doing something with my input. It understands what I want it to do. So the final sort of piece of the puzzle, if it can understand natural language, can it behave like a human in the sense that you could have a conversation with it? Can I actually, engage in some questions and answers? And again, the answer is there is a service for that. We have a service called Q&A Maker. And Q&A Maker allows me to define what we call a knowledge base, which is effectively just a database of questions and answers. Although it's a little more sophisticated than that. I can define things like follow-up so that I get multi-turn conversations where I ask a question and then it needs more information for me, so it asks for more information. And I've got a huge database here of these questions and answers. And again, I would train this model. So again, save and train, same pattern as before. It trains it with some natural language understanding, so I don't have to use exactly the same phrases as I've got on my questions. And then I can publish this as an endpoint. And in this case, I've published it, and then on top of that, I've built something called a bot. So I've got a bot that is built on top of my Q&A knowledge base. I've connected that bot to a channel called the web chat channel, which enables me to interact with it through a web page. There are other channels I could connect it to. I could connect it to a speech channel so that I could speak to it over a voice line or through a telephone or an email. I could send it an email and get a response back. So it's very versatile. I can use all these different channels to speak to it, just like I can with different humans. In this case, I'm going to use web chat. So I'm very quickly going to go back to my code. And I actually have, here's the HTML, it's just an iframe that connects to that bot. And here's what that looks like in a user interface. We get this little framework here. There we go, the space to type my message. So I could type hello. And it'll go and send that message to the bot, and the bot responds with hello. Okay, so that's good. Hello and welcome. We're ready to go. So I could say, this is all based on a thing called Margie's Travel. So I could say, what is Margie's Travel? And I get back a sensible response. Margie's Travel is a full service travel agent. Well, that sounds great. Oh, there we go. I am to serve. That's very nice. Okay, so can I book a hotel? Yep, we partner with the best independent hotels, blah, 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 blah. Here's how to book. What if I need to cancel a reservation? Well, cancellation policies vary. What type of reservation is it? Well, it might be a flight or a hotel cancellation, or you can cancel a flight or hotel anytime. So I'm getting a sensible dialogue with this bot. I'm having a conversation. Now it's very constrained. It's constrained in this case to the subject of Margie's Travel. If I ask it anything out of that, it will get a little confused. But because it's got that knowledge base and it's got some natural language understanding, it is able to interpret my questions, find the most appropriate answer in its knowledge base, and then furnish me with that answer and give me that conversational interface that I might expect to have if I were interacting with another human. So all of these things, we've very quickly, just in the space of 25 minutes or so, we've very quickly gone through lots of different ways of building solutions that have AI capabilities. They have human-like capabilities, and all of them are based on using some data, using that data to train a model, then publishing that model as some sort of endpoint that I can consume, and then building an application on top of that endpoint that allows a human to interact with the model that I've trained. Now, if you want to learn more about this stuff, we've gone through it very quickly. If you want to take your time and try all of this stuff for yourself, and why wouldn't you? There is this link here, aka.ms Azure Learn _AI fundamentals. And if I go and open that up, what you'll find there is a bunch of learning paths, a collection of learning paths with a whole bunch of free training that you can take online, and you can try this stuff out for yourself in an Azure subscription. You can go and create bots, you can create custom vision models. All the things that I showed you today are included in these learning things, so you can try and build out the grocery detector and the home automation language understanding model for yourself. You can see it sort of follows the same pattern that I did today. We start with machine learning, and then computer vision, then natural language, and then conversational AI for bots. So please, by all means, go and have a play with that for yourself. That is pretty much the presentation. So I'm going to hand back to Sherry and just get some final questions and answers in the last couple of minutes.
Hi, everyone. Well, thank you so much, Graham. And one of the questions that has come through quite a bit is we saw the work in the notebook in Visual Studio Code. Does a student need to know what Visual Studio Code is or how to program in order to start taking AI fundamentals and learning this material?
Okay, hopefully I wasn't on mute for the entire thing.
Oh, no.
Nope, good.
The others were good. You're good.
It is the learning is fundamentals. So we don't assume any prerequisites. We do provide a lab environment with everything installed. There is some code that we give you that you can run, and if you want to dig into that code, you can. But we don't expect you to be an existing programmer or an expert or anything like that.
That sounds awesome. And I guess as a closing question, because we're almost out of time, what's one thing you really like about Azure AI, Graham, and especially because you've worked with it and in implementing Azure AI, if there's a product that you really like in particular about it?
I think all of the cognitive services, the fact that they're building blocks means that I can start with what is the AI behavior that I want to implement, and I can find the appropriate building blocks and put them together the way that I want to build my app. So I can be very versatile about how I want to create that app, and a lot of the work is done for me. It's just a case of assembling the right unit.
Awesome. Yeah, well, thanks everybody. We're out of time, but I really appreciate you, Graham, and the audience for tuning in, and we will talk to you later.